So the first question is asking for what the domain is of G. And so your question is concerning what are you allowed to plug into this. And so I look at my function right here to see if there's any limiting operations. And this square root sign is a limiting operation. You're not allowed to have negative numbers inside of that square root sign. And so this is my thought process. I'm thinking I want t to the third power plus 64 to be greater than or equal to 0, because if it equals 0, that's fine. We can take the square root of 0. And so I subtract 64 from both sides, and then I take the third root of both sides. So when I take the third root of that side, I get that, and then I take the third root of 64, and I get 4. Actually, negative 4. So I'm thinking, okay, whatever's in t has to be greater than or equal to negative 4. So how would a negative 4 get there? Well, let's see. Whatever I plug into this x right here would first go into this squared, this x squared. And then whatever's in that x squared would eventually go into this guy. Well, kind of. It would kind of go into that guy. If ever you're taking the integral of a square root, whatever's inside there, let's just put an x. You would look at it as an x raised to the 1/2 power. And then if you're thinking about taking the antiderivative of x to the 1/2 power, you would get x to the 3 over 2 divided by 3 over 2. Well, because there's a denominator of 2 in the exponent, you know that there's going to be a square root over this x. So whatever the antiderivative is of this, you're still going to have a square root when you're done. It won't be this. This is just an example. I made this up because I don't think we could take the antiderivative of this right now. Even u substitution wouldn't work. But so thinking about this x squared, what happens to any number when you plug it into x squared? It's going to be greater than 0. It'll be 0 or greater. So this doesn't even matter. This just says whatever t is, it has to be greater than or equal to negative 4. Well, that x squared says, well, every number that's going to go inside the square root is going to be positive anyways. So because of that, that means because of that x squared, we can plug in whatever we want into G. So the domain of G, our answer for letter A, is going to be all real numbers. And even though this question doesn't say explain or justify, I want to go ahead and explain it. I want to say because x squared is always greater than or equal to 0. Alright, let's look at B. B says, find the intervals on which G is increasing. Now G is a function. And if we consider the big idea in calculus, the biggest idea ever, if we had G, we could take the derivative of G and get G prime. We could take the derivative of G prime and get G double prime. G prime tells us something about G. G prime tells us where G is increasing or where G is decreasing, because G prime gives us slope values. Whenever we plug something into G prime, we get slope values. So what I want to do here is I want to take the derivative of G. When I take the derivative of G, something really neat happens. We could use the fundamental theorem of calculus part 2. And the fundamental theorem of calculus part 2 says that when we take the derivative of an integral, the integral essentially just goes away. So we have t to the third plus 64, square root of that, and dt. Alright, so let's take the derivative of this thing. Now the 0 doesn't matter because that is kind of like the constant in the function. But this x squared does matter. So this x squared goes into the t. So we get x squared raised to the third power plus 64. And that's what you normally would do. If you take the derivative of an integral, that's all you would do. However, because there is a function that we are plugging in to the integrand, I think it's called the integrand, we have to then multiply this by the derivative of that. The derivative of x squared is 2x. Think of this like the chain rule, but with a function that's written in integral form. This right here is g prime. Once we got g prime, we can take that result and set it equal to 0 so we can find critical points. So we have 2x times x to the 6 plus 64. I got x to the 6 because of right here 2 x to the second power raised to the third power. You just take the 2 and the 3 and multiply them together. And I'm going to take this and I'm going to set it equal to 0. So if I take 2x and set that equal to 0 and this guy right here and set this equal to 0, you solve both of these. So we're using the 0 property. We get x equals 0. And on this side we square both sides and we get x to the 6 plus 64, and 0 squared is just 0. And then I subtract 64 from both sides to get x to the 6 equals negative 64, but because we have an even exponent, this is not going to give us any answer. So this will never equal negative 64 because if you have an even exponent, you're always going to have a positive number for your result. So this is our only critical point. So we're thinking here, we have 0. We need to know if we're plus or minus on this side and plus or minus on this side. And if we figure that out, then we could say on which intervals g is increasing. So let's plug in a number before the 0 and plug in a number after 0 into our g prime function. So we're going to plug in negative 1, see what we get, and we're going to plug in positive 1 and see what we get. Alright, so let's look at when we plug in negative 1, what do we get? So we're going to get a negative number right here, negative 2. Inside, we're going to have a positive number right there because negative 1 raised to the 6th power will give you a positive number. And then you would add 64 to it. Whatever that's, well, it's 65. So we have negative 2 times the square root of 65. That's going to be a negative number. So we're negative on the first interval from negative infinity to 0. For the second interval, let's see, that's going to be a positive 2. And we're going to get the same result. We're going to have 65 inside the radical. So it looks like in our second interval right here, we're going to go from 0 to positive infinity. That is where we have a positive slope. That is where this function g is increasing. So we would say from 0 to positive infinity, we put a bracket on the 0 because 0 is included in that positive. Actually, probably have. I know the book says to include 0, but that doesn't make sense to me because at 0, our derivative is 0, which means the function is neither increasing or decreasing at x equals 0. So I would say this is the interval where the g function is increasing. The last part of this question asks us to find g double prime of 0. So I'm going to find the second derivative of this. Well, it's the second derivative of this g, so that means I've got to take the derivative of g prime. And it looks like we're going to have to use the product rule because this function is multiplying to this function. And then we're going to have to use a chain rule because this function is inside of the square root. Okay, the derivative of 2x is 2, and that's multiplying to x to 6 plus 64. And then we're going to add 2x times the derivative of this second function right here. So we're going to first take the derivative of the outside function, which is going to be 1/2 times x to the 6 plus 64 raised to the negative 1/2. And that's because I changed that square root into a 1/2. And so I dropped the 1/2 and then took 1 away from the 1/2. That was my result. Next I'm going to multiply this by the derivative of the inside, and that's going to be 6x to the 5th power. Alright, so there is the second derivative. Inside of that I'm going to plug in 0 to see what we get. Alright, if I plug in 0 to this one right here, I'm not even going to simplify this. Check this out. 0 would be right here. This number would be a 0 multiplying to everything else. That just gets rid of it. So I don't even have to worry about this when plugging in 0. All I have to worry about is this one. So what do we get when we plug 0 into that part? We get 2 times 0 raised to the 6th power plus 64. So 0 raised to the 6th power, which is 0. So we have the square root of 64, which is 8. 8 times 2 equals 16. And that's what you get. That is g double prime of 0.